And I just want to kind of give you, we kind of ended last class session at the bell with explaining the ambiguous case, so I want to make sure we go through it and kind of understand why we're going through the calculations that we do. And I think if you understand why we're doing the calculations, then you will remember the process that you have to go through with those calculations. So here's the idea. Now, we've got an angle of 39 degrees and a side opposite is 35, right? And we got another side that's 46, okay? So I'm going to set up in GeoGebra an angle that was 39 degrees, okay? Opposite it was 35. So this would be the side opposite it, make it 35. And then the remaining side, what did it say it had to be? 46, okay? So 46. And it's going to make this thing here. Get rid of that. We don't need that in there. So it gives us this triangle, right? Or I guess it gives us these components. It's not a triangle yet. And this dotted line is showing you the potential place where the third segment would exist, right? Because that 39 degrees has to open up as 39 degrees, okay? But right now I don't have a third point because this segment is not intersecting essentially that segment. I got to find out where they intersect. So I start dragging this point, pivoting around A, keeping that 35, and we see right there, it creates a triangle, right? Okay. And at that stage, we have a triangle, and we can see if that's 56. And our law of sines, when we go through our proportion, is going to find us that 56. Okay. The next thing we'll be able to do is to take that segment there and find the fact that it's 55 or in the ballpark of 55. Is that all right? Okay. Let me just kind of draw a comparison over here with this picture. If this is, again, 46, and this is 35. Now, this doesn't have, just because I cut and pasting, there's some rules that I had to type in the background of GeoGebra to get these. You know, when I met that point right there on that ray, get these angles to pop up. It's not going to do that over here. But I think we can kind of interpret what's going to happen. All right, so I actually zoomed in at different scales, but it's the same triangle, right? We agree with that? My 39-degree angle is now down here, and this would be, when I intersect right there, take that segment and connect from B to C2, and you'd have this exact same triangle with the exact same parts. Does that make sense? However, if I keep moving C2, now I'm not creating a triangle, right? With this point here, all right, this point has to be on that ray. But at that stage right there, we do end up creating that triangle. Okay? Is that all right with everybody? And this is what we're referring to as the ambiguous case, because we could have the triangle in the yellow, or we could have the triangle in the white. Okay? Obviously, the triangle in the white is a little bit different than the triangle in the yellow, right? However, most of the calculations that we need for the white one have been done in the yellow one. Okay? And this is what I want you guys to understand, is that this 35 right here, correct? Is that going to be the same 35 when I move this thing over here and it intersects like right there? Does that make sense? So, if that is 35 there, and let's actually see if I can do this. Let's put a point right there. That's terrible. I don't like doing it that way. Let's just go ahead and put that in there. If that's 35, can I get to a point where the angle right above my cursor to the right, on the inside of that's 35, that's an isosceles triangle. That's that smaller triangle inside right here. Does that make sense? This would be an isosceles triangle. Okay. In this triangle over here, would that be the same as this triangle over here in white? Okay. So if this is isosceles, if that's 56, what's this one? That's 56 as well, right? Okay. And if roll, there we go. That would be 56. Okay. So what then, if that's 56, 56, and this triangle here is that triangle there, what does that angle right there have to be? 124, because it's got to be supplementary with that 56, right? Okay. So if I have the ambiguous case, or if there's going to be a second triangle that exists with the ambiguous case, then the second triangle's angle is simply going to be the supplement of that angle right there, which we're seeing over here as being that outside angle right there, 1.4 there, right? Does that make sense? But the reason we take the one, when we go through all the math and calculations here, you might see that you might think it's kind of procedural, where I'm just going to subtract from one angle. Why do I do it? That's the reason you do it, okay? Because the only time that second triangle is going to exist is when we move that that segment, that ray over, or segment over here, and intersect there. You end up ultimately creating an isosceles triangle there on the right, and we can then just kind of transfer values, okay? Transfer supplement values. Is that all right? Okay, so when we go through the math, we should end up with, a 124 down here, and then this segment here obviously is going to be a bit smaller than 55, right? I believe it becomes like 16 something, okay? But we should be able to go through the algebra to figure this out. Now, when we're doing this, I don't care what your pictures look like. Your pictures are solely for organizing your information, right? We've talked in geometry that looks can be deceiving, right? Okay. So don't really worry about how you construct your image, as long as you got 3 points, 3 vertices, 3 sides, that kind of thing. You should be good. Okay. Now I'm gonna put my points. Maybe I put A here, B there, C there. Feel free to jockey them around, move them wherever you want to. Your triangle will look differently than mine, but we should still be able to relate parts and still get the exact same relationships. Okay, it's the exact same proportions. Because when you have angle A being defined as 39 degrees, and segment A is 35, no matter where A would be, maybe you put A up here as B, maybe you flip-flop these two, right? So does that mean that has to go there, and now that has to go there? Does that kind of make sense to everybody? So it doesn't matter what your picture looks like, where you put your points, we're going to have that information. So now C would be 46, right? And I need to find then angle C. All right? So I'm going to write, this would be lowercase b, and they're calling it B1, so I'm sure I use a B1 as well. Can we argue that the sine of 39 over 35 is equal to the sine of C over 46? Okay, that's what the law of sine says, right? Take angles and the sides opposite and write them as a ratio. Angle and the side opposite as a ratio. So there should be one more ratio, sine of B, capital B, over lowercase b, right? Now if I do that, can I use that ratio right away? Can I make, because we're going to set up a proportion, right? So in a proportion we need 2 of these. Can I take that one and that one right away? No, because there's 2 variables in the one on the right, correct? So I need to take these 2 and set up the proportion, the sine of 39 over 35 is equal to the sine of C over 46. Cross multiply, get 46 sine of 39 is equal to 35 sine of C, right? Now what do I do to solve for sine of c? All right, because remember that c is stuck in that argument, right? That's a variable that's stuck inside that function. So we need to isolate the function first. So we'll divide both sides by 35. And we get something that looks like that, right? And now to get this, because we're solving for c, not sine of c. How do I get that c to come out? Inverse. So take the inverse of sine of c, and it leaves me with just c. But then you got to take the inverse of this side as well, right? And then that's exactly what you type in on your calculator. So we go second sine, 46 sine of 39, divided by 35. Oh, I missed I got the wrong answer here. I missed a parenthesis here with this 39. There we go. 55.8. Is that okay? Okay. So if that's 55.8, we have enough room then, because how many degrees are you allowed to have in a triangle? 180. So I got 55.8 plus 39. 94.8. Take that and remove it from 180. It should give me this angle over here to be 85.2 degrees, right? Does that make sense? So once you find that first angle, once you find that thing right there, you have the ability to kind of finish off. That's the necessary measurement to finish off this triangle. Find that. Now I can find angle B. And now that I can find angle B, can I take this ratio of sine 39 over 35 and set it equal to that ratio there? Because now angle B is now a known value, right? 85.2. Previously, we couldn't use that ratio because it had two unknowns. Well, now it's only got one unknown of B sub 1. So B sub 1, sine of 39, is equal to 35 sine of 85.2. Divide both sides by sine of 39. And that should leave me B sub 1, right? Type that guy in. 35 sine. Don't ever do that again. I was kidding. You're allowed to see these. I should type that in, right? Okay, and that gives me B to be 55.42. Okay, 55.4. And that would then be all 6 components. All 6 components of that triangle, right? You got all 3 side lengths, all 3 angle measurements. Okay. You could probably cover your mouth for Robert's sake. You got a big snot streak on the back of your shirt, Robert. Right. All right. Now, that being said, we solved that triangle. We know that one triangle exists. But we always got to think in the back of our mind, they start us off with side-side angle, and that's the situation that the ambiguous case could occur. Okay? So what we do with the ambiguous case, when it could occur, is you take that first angle that you found. Okay? The first angle that you found, and that's the first iteration of the law of sines that we went through, right? And that gave me the 55.8 degrees. Okay? So it gave me that angle right there. Okay? I know that the 39 degrees has to be part of my triangle, right? I mean, we've got some values here that have to exist. I'm just going to highlight the ones that we know, based off the problem, have to be maintained. That has to be 39, That has to be 46, and this had to be 35, right? Okay. We found this measurement through the first iteration of law of sines. Okay. We have to ask ourselves now, is there a second angle that could be used there? So the way we do that is we always take its supplement, 180 minus 55.8. All right, and that's going to give me 124.2. So now the argument is that angle C, and again, my picture is not going to be to scale, but I don't really care. We're saying that angle C could have the potential of being 124.2, right? Does that make sense? So it's either 55.8 or it's 142 or 124.2. Now we're just going to make sure, does that 124.2 work? Well, what do I mean by does it work? I know that I've got to have 39 degrees in my triangle, right? I now say that 124.2 is part of my triangle. If that number, that sum is less than 180, that means you have leftover angle measurement for that third angle, correct? Okay. So I do then have a measurement here. What's that going to be? 16.8. I have 16.8. Remove that from 180, so minus 180. I know I'm doing the subtraction backwards, but which means get rid of the negative. So you get 16.8, right, for that angle measurement. So that triangle does exist. Okay. Now I know I drew my picture kind of haphazardly. It's not to scale because obviously 124 is an obtuse angle, right? Okay. So really, what this picture should look like is what we were seeing over here in GeoGebra, where it's this picture here on the right. Okay. That angle will be 124.2. If we were to find what that segment length right there is, it's messing everything up when I do that. If I were to find the segment length between that point B and that red X, it's going to spit back, I think something like 16, something like that, 16.1. Okay. Now, there is more to this question because you have to solve this triangle now, right? Solving that triangle means find all the parts of it. Well, we know that's 46 because that was part of the problem, right? We know this is 35 because that was part of the problem. Okay, we see that there. This B sub 2 is the remaining side that we would have to find, right? And can I use the law of sines again? Can I say sine of 39 over 35 is equal to sine of 16.8 over B sub 2? And then law of sines, cross multiply, and evaluate, and you should get that 16.1 that is showing up there in that green answer. Does that kind of make sense to what we're doing there with the law of sines? Okay, in the ambiguous case. And you only have to do that on side-side angle. When those parts are given to you, that's all you have to do. In the homework, sometimes it's kind of obvious that the ambiguous case is existing because they give you, that one column of B1, B or C1, and then lowercase b1. And in the second column, they give you angle B2 and angle C2 and lowercase b2. That obviously tells you then you probably have 3 triangles, right? Okay. Some of you might get triangles, though, or questions that look like, I guess I got to open it real quick. Something like this one, where it says A is 25, C is 47, and angle A is 129. Now, your numbers are going to change, right? Because the ones that are red are the ones that change per person. So I get a question here that says does not exist. Okay? I just want to show you an example where the ambiguous case could be a situation where they just give you parts that initially don't even create one triangle. Okay? So the ambiguous case, you could have 0 solutions, you could have 1 solution, or you could have 2 solutions. And this is the case that would occur with something like that. Now, I'm not going to use the same distances that question was asking, but this is the idea of that question. We need to swing this thing around so that it touches, if I got a 115 degree angle, it's got to touch this ray here to create another segment, right? To create our third segment. Will it ever touch? No. Okay. Never touches, but here's the math, because obviously when you draw the picture out, you may draw it, obviously, because you don't know yet. You don't know this isn't going to work. So you're going to draw it like it's probably a triangle. And again, the picture is just to organize your thoughts, to see what things that you compare. Maybe I call that C, and this would be 47. So there's B and lowercase b. Going through my work, the first thing I have to do is try to find angle C. So I got sine of 129 over 25. That should equal the sine of C over 47, which should equal the sine of B over B. Those are my three ratios. I know, and hopefully you do too, that you initially have to choose those two to do our work, right? So when I do the law of sines with those, cross multiply, I'll get 47 sine of 129. It'll eventually be divided by 25, and that will equal sine of C, right? To solve for C, what do I need to do? Inverse sine, so I'll take that and put that over here. All right, so I type that in. Second sine 47 sine 129. If you're a person that feels like you've been doing the homework correctly, but you're continually getting them wrong, check your mode on your calculator, okay? Because you could be doing every step exactly the same, but your mode might be in radians, and you're getting things wrong. Hit enter, and it gives me that. Okay, error. And what's nice is it tells me it's a domain error. Okay. And let's talk about what we mean by our domain error. If you remember, the sine inverse of x, okay, gives output values, and x was our input, so x is our domain, and we had input values of the sine function, okay, to be from -1 to +1. And they spit back then angle measurements from -90 to +90, or -π/2, +π/2. That was our information about the sine inverse, right? Input values could only be between -1 and 1. So my calculator just gave me a domain error. So what's that tell you about this number right here? Yeah, it's bigger than 1, or bigger than, or smaller than -1. Okay, so to the right of +1, or to the left of -1. So I'm going to go back to this. I'm just going to delete out the sine inverse and just calculate, see what that is. So that's 1.46. So the calculation is actually taking sine inverse of 1.46, and we know 1.46 is not a valid input value for the sine inverse. And that's why, or that's the algebra that shows up to you, the numerical response that shows up to you, that tells you graphically that that thing's never going to touch that ray to create a third side. All right? Okay. So that's the ambiguous case. There are times, obviously, the ambiguous case only gives you one solution. So that situation would be, if we go back to maybe this question here, we found this to be, 55.8. Okay, let's say that we would have gone through all the work, and we would have found this angle measurement to be 20 degrees. Does that leave measurement for that angle? Yep. Okay, so that would be one triangle, correct? But what is, we always take the 180 minus that 20, so 20 would go here. We'd get back 160, correct? With that having to be 39, can this angle here be 160? No, because that gives me 199, right, for my total number of angles used so far, and that blows up my triangle. That violates or contradicts the triangle angle sum theorem that says you have to have 180 degrees exactly in a triangle. Okay? So that's a situation where the ambiguous case only gives you one solution. All right? Is that all right? Does that kind of make sense on what we're trying to be able to do with that thing? Okay. Tomorrow's quiz, I'm not going to give you an ambiguous case question, but the law of signs there'll probably be a law of signs question on there. This question, which was from 5.5, I think. This is an assignment that had like 12 questions in it. This is a hard question because it does create the ambiguous case. All right, so and we have to have a little bit of geometry sense about us to really understand what our numbers are telling us. I think throughout the question, I cut and paste it. This was 25. Let me actually go back because I did this with the last class. All right, 25 and 34. All right. All right, so this measurement, U was 25, V is 25, and W was 34. So you have two triangles here. We want to work our way around, and we want to find angle BCD and angle DCA, which those are, just highlight them, talking about them a little bit easier. This yellow angle and that blue angle. Now, if you remember back to geometry, and trig is very well aligned with geometry. I mean, if you think about geometry, it's all about triangles, right? So it is basically an extension or a prerequisite to really getting into trigonometry, okay? There were never really directions in the question. It said solve for this, okay? That's all it gave you, but it didn't tell you how to go about to do it, right? You don't know where to start. There's not a procedure that comes with directions. Where like in an algebra class, it might say, factor this polynomial. So now you know the procedure is the factor, right? When they just present this to you, you've got all kinds of things that maybe you need to use, okay? If you struggle on a starting point and you've got multiple triangles, you're going to want to try to start. Don't look at it holistically. Don't look at all the triangles together. Look at the individual triangles, the smaller ones, and see if there's one that you know more things about than the other one. So if I look at the triangle that has the yellow angle in it, how many parts of that triangle do you know? You know two, right? You know the two sides. It tells you it's isosceles. That's nice. That's going to be information that we need. We only know two parts of that. How many do you know of the triangle that has the blue angle? You know three parts. So it probably makes most sense to start in the triangle that you have the most information about. Start in the one with the blue angle. So when I start with the one with the blue angle, the goal is to find that angle right there. So I'm going to ask myself, can I do that? And I'm only going to be looking at this blue triangle right now. Only looking at this guy. Would you agree if I'm just going to call that angle up top C? Okay. Would this side here be lowercase c? All right. So I'm going to use because it's not a right triangle, correct? And if I'm trying to find angles and distances and non-right triangles, right now our only tool is the law of sines. So I say sine of c over lowercase c is equal to sine of, I'm going to call this angle D down here, okay, over 34, which is then is equal to the sine of A over, sorry, sine of 30, because that is A, right, over 25. Those are my three ratios for the law of sine. Now I somehow call it angle D and call it angle C, because holistically for that whole triangle, if I say angle D, there's actually three angles at angle D, right? If I say angle C, there's actually three angles at angle C. So those are kind of bad ways of defining them, but if I know I'm only looking at the blue one, I don't think there's confusion there. I can't directly solve for sine C, right? or I can't directly solve for angle C here because there's two variables in that ratio. So what I need to realize is that these two ratios are where I've got to start. I have to first find angle D before I can find angle C. So I'm going to say 25 sine of D is equal to 34 sine of 30, right? You don't have to do it this way, but what's the sine of 30? Does anybody remember? 1/2. What's half of 34? 17. So that side is actually 17. If you want to leave it as sine, or 34 sine of 30, that's fine. I just like to do it this way because now if I've got 25 sine of D is equal to 17, I can divide both sides by 25, right? So now I got sine of D is equal to 17/25. So D then is sine inverse of that, right? And I like to type in a 17/25 instead of 34 sine 30 over 25. But regardless, however you type it in, if you do that reduction throughout the problem, it's easier to type in, but you're going to get the same answer regardless. So 17 divided by 25 gives me that angle to be 42.84. Okay? So angle D, 42.84. Now, don't ever go off of looks, but that angle doesn't look like a 42-degree angle, does it? All right? Don't ever go off looks, but it doesn't look that way. Okay? Would that tell me the angle C then? If I add 30 to that, and take that number, remove it from 180, gives me angle C to be 107.156. Is that okay with everybody? Now, if you're blatantly, blindly, I guess, doing this math, being robotic, and this is where hopefully throughout the courses you've taken with me, you start to realize that we don't want to do that, you would maybe make some drastic errors here because you can go through this and find a bunch of values, but if you're not paying attention to the potential of violating properties and theorems and stuff like that, you're going to incorrectly or answer this question incorrectly. If that's 42.84, this is 107.15. That was 30. That's a triangle. That's fine. How is this angle here related to that angle there? Supplementary. So I should be able to take the 180 minus that angle there and get 137 right here, correct? 137.15. So, because this triangle on the left has a 25 here and a 25 there, what kind of triangle is the white triangle? Isosceles. What do you know about the base angles of an isosceles triangle? They're the same, so that's 137.15, right? What happened there? Went over 180, right? Okay. So, that means this angle here could not be 42.84. Okay. This triangle on the right is an angle side-side triangle. It's the ambiguous case. The 42.84 doesn't really work. But its supplement might. Does that make sense? Okay. What's 42.84 supplement? 137.15. So what really happens in this question is that these two numbers just flip-flop, right? Okay. So if that's the case, this top blue angle is going to be, my 137.15 plus 30 minus 180, or removed from 180, and that top angle should be 12.8. Okay? And that's what we're seeing right here as our answer for DCA. And now if this is 42.84, what's this angle over here? Yeah, that's 42.84 as well. And now can I take that 42.84, multiply it by 2, and remove that from 180? And give this top angle here, this yellow angle, to be 94.3? Okay. There's a lot involved in that question, right? Law of signs, the ambiguous case, understanding of supplementary angles. understanding of triangle angle sum theorem and all that kind of stuff. There's a lot of stuff going on in there. And that's the thing about a geometry class, that's the thing about a trigonometry class, is there's a lot of properties and a lot of theorems that are all kind of intertwined, and we have to make sure that we don't contradict any of them. We have to make sure that with triangles like this, when you've got multiple triangles, that one triangle never contradicts information about another one. Okay. I'm not going to give you a question like that on tomorrow's quiz, but there may be one similar to that on an exam at some point. Going through a couple other ones from that assignment, there were some story problems that I had a lot of people questioning. So I'm not sure what number this one is, but there's a satellite question. Okay, if we read through it, I closed it out on accident, but it says two satellites A and B, two state radio stations A and B are 95 miles apart. Okay, so A to B, between these two satellite dishes, they are 95 miles apart. Okay, they say the satellite says it's on one side of both stations, meaning that satellite either has to be there or over here. It cannot be here, right? Because that's not on one side of both. It's on the right-hand side of A, and it's on the left-hand side of B. Here, it's on the left-hand side of A and the left side of B, right? Okay. Now, I don't like their picture, but they're trying to stay to scale. Because if this is 87 degrees, that's pretty close to 90, right? And 90 degrees is looking straight up, correct? Okay. I like to maybe make it a little bit more I guess less abstract, less confusing, because I think a lot of people had trouble with where the satellite really was. Okay. Now the information they give you is that this angle out here is 87. This angle in here is 84.2. The 84.2 is nice, but this 87 isn't really good. Okay, because that's not an angle in my triangle, right? What's this angle in here going to be? It's going to be the supplement, right? It's going to be 93. This angle up here then has got to be 2.8. Is that doable? Okay. So now the question was, how far away is satellite, or the satellite from station A, and how far away is the satellite from station B? Can I now say that the sine of 2.8 is equal to 95, or divided by 95, sorry, is equal to the sine of maybe 93 over x, which is equal to the sine of 84.2 over y? Does that make sense? So those are my three ratios. Pick out, obviously, the first one, and maybe the second one. Now I'll solve for x. Pick out the first one and the last one, and now I'll solve for y, right? Okay. My hopes are that we can do the algebra, okay, cross multiplying, that kind of stuff. So I'm going to stop there with that one, just so we can get through a couple more examples here and how they're supposed to be set up. I guess maybe I got to open the assignment.
Pardon the interruption. This is just another quick reminder that the Interact meeting that was scheduled for Wildcat Time today has been canceled. Again, there will be no Interact meeting during Wildcat Time today. Thank you.
All right, there's a question about this airplane, right? Says the two mile posts are 10 miles apart. Okay, so A to B is 10 miles, right? We also say 31 and 40. Okay, so they say at this angle here is 31 degrees. This one's 49 degrees, right? A to B is 10 miles. Now, these are angles of depression, and they are not parts of this triangle on the inside, right? Okay, and it's a non-right triangle, but what do you know about that segment there compared to the horizon? They're parallel. So you have parallel lines cut by this red line of sight, which is a transversal. So what's that tell you this angle right here is? 31. What's that tell you this angle right here is? 49. So now the question is, how far is the airplane from A? So maybe that's Z. And how far is the airplane from B? Let's call that W. Could I say the sine of 31, sine of 31 over W is equal to the sine of 49 over Z? Now what's the problem with that? Two variables. So I need maybe the third one, which would be the sine of, what's the third angle? Yeah, that angle right there has to be 100 degrees. So sine of 100 over 10. And now you have to use that ratio with any of the other two, and you should be able to find W and Z. Okay? I will, because I know, just because of past years, that question with the tree on the hillside, anybody struggle with that one? I think that was maybe one of the, just kind of trying to jog my memory from previous years. I think I've had a lot of questions about that in the past because of that angle A and angle B that they're giving you there. So I'll put a quick video together during third period about that and get that online or send that out to you in an email so you can answer those.